Hey everyone, if you recall, last time we were taking a look at this NEA versus fat gained and trying to look at the correlation, and I showed you how to build that formula, which, if you remember, was, and I'll just put it in here, y equals a plus bx. And we ended up saying that b was really equal to whatever our correlation was times the standard deviation of y times the standard deviation of x. And we also needed a, which was equal to the average y minus b times the average x. All right, so we figured those things out. I put the formulas in here to find that. So really, if you're calling that last one, I ended up having a formula that looked a lot like this. Y equals negative 0.003 plus 3.5 times x. All right, that was the equation that we had kind of building it by hand. And if you recall, it was a little bit tricky because I had to change my scale because I had drawn it differently. Well, today we're going to take a look at doing these same things again, just with some of the statistics that we have here built in. So I'm using Google Sheets right now. And I'm going to move this down here. This is all the stuff that we found out. So I'm going to grab these things and drag them over here and say, yeah, this was the stuff that we did by hand. And we're going to show you how easy it is to do this stuff by using this. So we did the correlation before. If you remember, that's how we got R. But I also did the correlation, which is the correlation feature. Let me show you some of the things that we have over here. So the first one I'm going to show you is called the Descriptive Statistics, and this is also in Excel as well. So remember, in Google Sheets I do it differently. I'm going to do the input range by selecting first and then clicking right here. These are grouped by columns for each one. There is a label in the first row, and the output range, I'm going to put it right here in H1. Okay, and so it's going to show me a bunch of things, and I just left the rest of this selected. The summary statistics is what I'm after. I'm going to highlight a couple of them for you. Now I did it, and let's open up a few of these so we can see what they are. All right, so notice, and again, here is our x value, is the NEA, and here is our y value in fat. And a couple of the ones that I really want you to pay attention to, because it's really helpful, we did these by hand before, is it gives us right away, it gives us the mean for these things. That's one of the things that we constantly am looking for. Median and mode, we worked with those in the last chapter, so it's really nice to see those. But here's what's really important for our calculations is the standard deviation. Again, you'll notice it throws the standard deviation. We found it by hand before. Throws both of them together for me. Okay, and it also gives us some of the other parts of our five number summary, the minimum and maximum numbers. But for me, the one thing that I'm noticing that they don't have here is that correlation. All right, so it doesn't give us the correlation, but it does give us a lot of really interesting statistics, things that we can use as we go through it. And we talked about it, even something called skewness, so that we can help see whether or not this thing skews left or right, etc. But those are two of the big ones, the mean and the standard deviation. Okay, now I'm going to show you another one that has a lot more options in it, and it is, since I've already looked at this data, and you could do this again. You could say, I'm going to take this data and I'm going to insert a chart. And I don't even have to go past inserting a chart to see, like, oh, this data looks pretty linear to me. So I know I want to use kind of a linear chart. So I'm just going to throw this one in here for right now, because we'll come back to it. Here is the chart that I would maybe use originally, and say, like, oh, yep, that looks like a straight line. So let's shrink that up and put that up here. All right, let me get one that gives us a little bit more options and gives us a lot more of the statistics that we want to use. And that is going to be, since I know it looks like a straight line, I'm going to use a linear regression. And notice it wants y and x separately. So here is going to be my y. Here is going to be my x. I have labels in the first row. The constant is 0. Remember, that's the intercept. My intercept doesn't look like 0. I usually leave that out. But what I want to do especially is know, we'll look at residuals later. I really want to know the line fit plot. Okay, so I'm going to hit the line fit plot, and I'm going to put this, I'm going to put it right underneath here and hit OK. Oh, hit output range first at H20 and then hit OK. And now it gives me a number of additional statistics, and I'll pull this graph over here really quickly. So here's the graph it gives me. Same one, but I'll show you what it also has. We have right here, we have multiple r and r squared. And we'll talk a little bit about r squared later, but this really is two of the things that we want to know. And that r squared really talks about how confident we are. It'll talk about how well this thing fits this data. And so this one's got a 60 or a 0.6. We'll talk about that a little bit later in the chapter. But what I'd really like to do is, now that I've got, notice I have everything that I needed. I've got my x average and y average. I've got my standard deviations, and I've got r, that I could really put together these formulas again. You know, I could do it by hand. What's really nice, though, is that most graphing software, including graphing calculators, will actually give us the equation as well. So I'm going to make this a little bit bigger. I'm going to right-click on it and go to Advanced Edit. And what I'm really looking for is, I want to make a trend line. And I think it's a line, so I'm going to put a linear trend line on here. And for the label, and this is what happens when I put a label over there, it's called Trendline for Series 1, I'm going to make it the equation. I really like that part a little bit better, and so I'll update that graph. And look at this equation. If you don't remember, e to the negative 3 really just tells me I'm moving the decimal point 3 places over. Well, that means it's y equals negative 0.003 plus 3.5, or excuse me, y equal, and I'm reading this wrong because it's a little bit wider there. Let me make this a little bit wider, make this a little bit narrower if I can. Oh, it's probably not going to let me, is it? Yeah, so anyway, this equation right here really is the same equation that I have over here. All right, so it did all of that stuff I did by hand in the last one, and it throws it together for me, and it gives me that. And I like when I'm looking at this in Google Sheets, I can turn on the eyeball, and there it's a little bit easier to read. They put it in the standard format. The only difference, instead of putting it like this, in fact, mine's actually wrong over here. This isn't what I had before. We had y equals negative, or 3.5 minus 0.003x. All right, that's what they have, but they wrote it in this form: y equals negative 0.003x plus 3.5, which is a little bit more like the form I would normally go with. And I think if you look over here, what we did last time, that's exactly what we had. Here's our 3.5 minus 0.003x. So once again, or minus 0.003x, telling me that that slope is going down. So that is exactly what we found out before. And like I said, it's a really simple process to do that using Google Sheets. Plus you get a lot of extra statistics that we will take a look at kind of going forward. One of those is the r squared. All right, so that's doing the exact same thing in Google Sheets. I'm going to put together one more video on this and doing that in Excel as well. And kind of walking through the same idea. I might use a different data plot so that if you want to see something different. But no, I'll use the same one just to make sure, and then we'll have some time to talk about that.